I'm Anil Kumar, sharing with you a test question on writing equation of a polynomial function when zeros are given. The question here is, write equation for the following polynomial. A quintic polynomial with zeros -3, -2 order 2, and 2 order 2 that passes through the point 1, -18. You can always pause the video, answer the question, and then look into my suggestions. Now let us see what is given to us first, right? Let's see what is given to us. We are given that quintic polynomial. That means quintic means what? Degree 5 polynomial. Is it okay? Now we are given 1, 2, and 3 zeros. Now we are given zeros. 1 0 is at x equals to -3. Let me write x equals to -3. Okay. Now a zero of this kind will give you a factor which will be x plus 3. Is that okay? Let me write like this. This gives you a factor. Now the next zero is given to you at -2. So x equals to -2, and the order is 2. Order is 2. That really means that the factor should be x plus 2, ensuring 0 at -2. Order 2 means to the power of, right? And then again we are given a 0. See, zeros and x-intercepts. Zeros have order, x-intercepts we don't talk about, right? Order. X equals to 2, order 2, right? And that gives you a factor x minus 2. That makes it 0 at x equals to 2, right? Order 2 means power of 2. And it also goes through a point. Let's call this point P 1 minus 18. Now since the point is given to us, we'll actually be sketching and also first writing the equation of a polynomial, a very specific polynomial. Okay. So this specific polynomial could be represented as a function f of x equals to a times these factors x plus 3 times x plus 2 whole square times x minus 2 whole square. Perfect. To find a, we'll use the point 1 minus 18. 1 is the x value, minus 18 is f of x. So we get minus 18 equals to a times 1 plus 3 times 1 plus 2 whole square times 1 minus 2 whole square. Minus 18 equals to a times 4 times 3 square is 9, and this is minus 1 square is plus 1. So we get minus 18 equals to 4 times 9, 36. A minus 18 over 36 is the value of a. So we can write this as a equals to minus half, correct? Now since a is minus half, we could write the function f of x as equals to minus half x plus 3 times x plus 2 whole square times x minus 2 whole square. So that's the polynomial function. Quintic, degree 5, 2 plus 2, 4, and 1, 5, which represents the given condition, correct? Now as an added exercise, let's try to sketch this function. We're given zeros at -3, -2, and 2. So let me take this as x-axis, y-axis slightly on the right side. We have zeros at -3, let's say, -2, okay, and 2. Since the leading coefficient is negative, the end behavior is kind of from quadrant 3 to quadrant 4. Is it okay? Now, at -3, we have a linear zero, so it'll cross like a straight line. However, at -2 and at 2, we have even zeros, so they will kind of turn. Joining these points, we can sketch, right? So we could start from anywhere. We could say Okay, let's do like this. And then we can go like this. Is it okay? So that becomes the graph of the quintic function. It'll go through a point which is 1 minus 18. So let's say at 1 this point is minus 18. Is it okay? This is minus 18. You can always find the y-intercept by plugging 0 for x. We'll leave that for you. So that becomes the graph for the function, right? That's point P, which is 1 minus 18. So I hope that helps. So graph really moves from quadrant 2 to quadrant 4. That means when x approaches negative infinity, y approaches positive infinity. And when x approaches positive infinity, y approaches negative infinity. The function doesn't have any symmetry, as you can see. It is quintic function with 3 zeros, 1, 2, 3, 4 turning points, 1, 2, 3 x-intercepts. That's what you can say about it, right? You can always find the y-intercept also. Let's take this as an exercise. I'm Anil Kumar, and I hope you like the video. You can always put likes there, share with your friends, and post comments. Thank you for watching. Thank you.